Oh yeah, the inter school.
Yeah,
Yeah, sir. We won, sir. We won nationals.
very good,
Mm.
very good. So in the last class, we have discussed uh, about the mirrors, concave
Yes.
and the convex mirrors. We have just completed the introduction part, and so I have told you about the mirrors. What is principal axis, what is pole, and how the spherical mirror formed. I have already told you. So today we will discuss the
Yes.
focus and the focal plane of the concave and the convex mirror. Focus and the focal plane
Focal
of the
plane.
concave and the concave mirror.
Convex mirror.
Yeah. So how we define the focus? There is a way to define the focus. Okay, so focus. Hmm. For example, this is a concave mirror. We know this is a concave mirror, and these are the parallel rays of light, and these rays are parallel to the principal axis also. This is the principal axis.
Yes, sir.
This is a concave mirror, and this is pole, and is uh, hmm, this is the center of curvature of this concave mirror, and these rays are the parallel rays, and these rays are parallel to the principal axis also. Principal axis. So the line joining the center of curvature and the pole is the principal axis, and
Yes, sir.
pole is the middle point of the mirror. Pole
Mirror.
is the middle point of the mirror. So in this case, now what will happen? Whenever the rays are parallel, after reflection from the mirror, so here the reflection will. This is the ray of light coming,
Yes, sir.
and here the reflection will take place. Reflection will take place, and after reflection, this ray will go. Uh, this ray will go like uh, this, for example.
Yes.
Okay, after reflection, so this ray is going like this. This is the parallel ray, and second ray after reflection going like this, and meeting the first reflected ray at a point, and this point is known as the focus. So all the parallel rays which are parallel to the principal axis after reflection meet at a common point known as the focus.
Focus.
So this is the focus of the concave mirror. So rays of light parallel to principal axis after reflection meet a common point on principal axis. This is principal axis called focus.
Focus.
Hmm. Now, in case of the convex mirror, in case of the convex mirror, what is focus? Hmm. Hmm. This is the convex mirror.
Yes,
This is
sir.
the convex mirror. Okay. No problem. These are the parallel rays, and these are rays parallel to the principal axis also. So
Yes, sir.
this is the reflecting surface. This bulging outward surface here is the reflecting surface. Okay, bulging outward surface is the reflecting surface, and here is the pole. This is pole, and here is the center of curvature, and this line is the principal axis. So these
Yes, sir.
rays of light are parallel to the principal axis. Okay, so now what will happen? This ray of light is striking the mirror at this point, and this will be reflected. This will be reflected. Okay, so this will be reflected. Suppose like this. Uh, this ray is reflected like this. Okay, so so this ray of light after reflection going in this direction, this is the reflected
Yes,
ray,
sir.
and now for this ray, this is also parallel ray. So and now so this is the reflected ray again. This is the reflected first reflected ray is this, second reflected ray is this. So now both these reflected rays are diverging in nature. These rays are just diverging, and we know that diverging rays will never meet. Diverging rays will never meet. So in this case, now what we will do, we will just produce backward these diverging rays. We will produce backward these diverging rays. So where these diverging rays after producing will meet will be the focus of the
Focus of the
convex mirror.
yes. Yes.
Convex mirror this time. This is the convex mirror. And this will be the focus of the convex mirror. So suppose here with the center of curvature, and this is the principal axis. So now you can see the definition. Rays parallel to the principal axis after reflection
After reflected
diverges.
reflection diverges.
The divergent rays on being produced, the divergent rays on being produced backward meet at a
Meet
common
that
point
common
called
point called
focus.
for focus.
Focus. Yeah. Now you can see here. Are these rays meeting actually, or just these rays are just appearing to meet?
Appearing.
Appearing to meet. So
Yes.
this focus is not the real focus. This is the virtual focus.
Yes, sir.
So that is why the convex mirror have the virtual focus. In case of the concave mirror, rays are actually meeting, so it will have the real focus. It will have real focus.
Real focus.
Okay, this is the about focus. This is about focus. Now we will talk about the focal plane, and focal plane is something different. See, what is focal plane? Earlier, this time I have told you rays are parallel to the principal axis. Suppose what happened when these rays are not parallel to the principal axis, but these rays are parallel to itself. Then where after reflection the rays will meet. So that will be defined by the focal plane. So this is a concave mirror. This is a concave mirror, and these are the parallel rays. These are the parallel rays, and these parallel rays are striking on the mirror at this point and this point. And now you can see these rays are not parallel to the principal axis. Are these or not? Not na?
No, sir. No, sir. They are not parallel.
Not parallel to the principal axis.
Yes, sir.
So now what will happen? The reflection will take place. Reflection will take place. So how these rays will reflected, we will see. Uh, this is a reflection of this ray,
Yes, sir.
and this is the reflection of this ray. This is the reflection of this ray. So After reflection, this is going in this direction. After reflection, this is going in this ray, incident ray, reflected ray,
Yes, sir.
incident ray, reflected ray, and
Refracted ray.
these rays are meeting at a point. Suppose this point is M. This point is M, and this is the pole. So these rays are meeting at a point M. Remember, this
Yes,
point is
sir.
not a focus. This point M is not a focus. This point is a point lying on a focal plane.
On a focus plane. Yes.
Focal plane. This is a point lying on the focal plane. So focal plane will be something like this. So this is the focal plane. Now what is the focal plane? Focal plane is a plane when light rays are parallel. When light rays are parallel, striking on the mirror after reflection, meet at a common point, and that common point is lying on the focal plane.
Yes,
Focal
sir.
plane is a plane. Focal plane is a plane when the light rays are parallel after reflection meet at a common point. Focal plane is not a matlab is a special type of thing. Focal plane is a plane simply, but the
Yes, sir.
special thing about the focal plane is the parallel rays are meeting always at the focal plane.
Yes,
Parallel
sir.
rays are always
Or
meeting
always
at the focal
meeting
plane.
at the focal plane.
Like you can see here, these are also parallel rays. This is first parallel ray and this is second parallel ray. These rays are meeting at this point focus, and this focus is lying on the principal axis, but this focal point is also lying on the focal plane. You can see here,
Yes.
these are the rays, these are the parallel rays, and this is the pole. So in this case, what will happen? These rays will meet like this. Here will meet these rays. Meet at a common point called focus. When the rays are parallel to the principal axis, now, so these rays meet at a common point on the principal axis. On the principal
Yes.
axis. Okay. But this point, this focal point will also lie on the focal plane. Will also lie on the focal
Plane.
plane. Yeah. So this is also a focal plane. Means this focus is also focal point is also lying on the focal plane.
Yes, sir.
So this is the focal plane of the concave mirror. We have defined the focal plane for the concave mirror. Now for the convex mirror, we will define. Now you can see set of parallel rays. The definition of the, if you want to write in an exam what is focal plane, then you have to write like this: set of parallel rays of light. Set of parallel rays of light after reflection from a concave mirror. After reflection from a concave mirror, meet at a common point. Meet at a common point, lie in a plane called focal plane. Now for the convex mirror. Now for the convex mirror. Okay, so this is the convex mirror, principal axis, and this is a convex mirror. Now these are the parallel rays, and we know that the parallel rays. Now we know that the parallel rays will meet at focal plane. Means meet at a point at a focal plane, and
Yes, sir.
you can say parallel rays always meet at a point, and that point always lie on the focal plane. So now see how here a thing will happen. This is a convex mirror. This is a convex mirror. This is the principal axis. Principal axis. Okay. So now two incident rays are there, and these two incident rays are parallel also. So first incident ray, suppose like this, reflection is taking place like this. Okay, so and for the second incident ray, suppose uh, this incident is taken. I mean, the reflection is taking place like this. Okay, so now you can see both reflected rays are diverging in nature. These are diverging rays, and diverging rays will never meet.
Yes.
So
Yes, sir.
simple funda we will apply. We will produce these rays in backward and in backward direction. Backward means inside the mirror they will meet. Inside the mirror. Have you seen the image of yours in your plane in the plane mirror at your home? Obviously, you have seen.
Yes, yes, yes.
We have all have seen that. It's very normal thing.
Yes,
So
of course.
the image the image that is forming in the plane mirror is inside the mirror or behind the mirror?
The image forming is
Okay.
it's inside the
I
mirror,
also have
right?
yeah, it's inside the mirror. I actually here also I have a plane mirror I can show you, but there is no requirement. But just think, basically
Yeah,
the image is inside the mirror,
inside
not
the mirror.
behind the
Yes.
mirror.
Yeah.
Behind the mirror is there is some there is you can think there is another world or another dimension inside the mirror. Okay.
Yes.
Okay. It is not true. Just I'm telling. So here now you can see after these reflected rays from the convex mirror are meeting means reflected rate when these reflected rays you are producing in backward direction, these rays are meeting at a point. This at this point these rays are meeting at this point. So now if these rays are meeting at this point, so you can say that this point will lie on the focal plane.
Yes, sir.
So here it will be focal plane. This point, suppose M is lying on the focal plane. Focal plane and principal axis. Okay, no need of principal axis. We know what is principal axis. So this is a definition you can write. Set of parallel rays after reflection. Set of parallel rays. These are the parallel rays. Okay. These are the parallel rays. So set of parallel rays after reflection. After reflection, these divergent. These are the divergent. These rays after reflection becomes diverging in nature. These rays are getting diverged from the mirror. These rays divergent rays. These rays on being produced backward meet a common point, and common point here the common point is M. These common points always lie in a plane called focal plane. Now you can note down. Scroll down.
So just a minute. I'm drawing with pencil, so that's what.
So try to draw the rough diagram, okay? When in
Rough.
exam, just try to draw the rough diagram. Why? Because we have a limited time. In
Okay,
exam, you
yeah,
have to
okay.
draw. In exam, you have to draw with the scale and all those things you have. But here, there is no requirement of drawing the diagram, because you will revise this diagram again. Obviously, when you will do the revision, then you will revise this diagram. Then you can draw that.
Yes,
So
sir.
it is better here is this time to draw a diagram just roughly. No problem.
Okay. So guys, hold on. So guys, hold on. Second scroll down. Second scroll down. Done, sir.
This is completed.
Yes, sir. Yes.
Okay, now we will discuss focal length. What is focal length? We will discuss. Very important in case of the
Yes.
mirrors. Focal length. Mm. This is the concave mirror, and we are discussing focal length. Focal length. Okay. So So this is a concave mirror. This is a concave mirror, and this is a pole, and principal axis. Uh, if this is a focus of the okay, so this is the focus of the concave mirror. This is a
Yes, sir.
concave mirror. This is the concave mirror, and this is the focus of the concave mirror. Suppose a ray of light is coming parallel to the principal axis, parallel to the principal axis like this, and here somewhere is the center of curvature. In the beginning, I have told you the normal, we draw normal. The normal
Yes, sir.
always passes through the center of the curvature. For this incident ray, this is the incident ray. This is the incident ray.
Incident ray.
This is the incident ray. And this ray is striking at this point. So there is a requirement of normal here for the angle of incidence and for the angle of reflection. So normal will be like this. Suppose this is the normal. I have told you, na, in case of the spherical mirror, in
Yes,
case
sir.
of the
Yes.
spherical mirror,
Yes.
I think here I have told you. Normal will always pass from the center in case of the spherical mirrors. So this concave mirror is also a spherical mirror, na, part of the sphere. So the normal will pass from the center of the curvature. So suppose this angle is theta. And what is this theta? This theta will be the angle of incidence. This
Incident.
theta is the angle of incidence. So after reflection, this ray will meet at focus. Obviously, parallel
Yes,
ray
sir.
meet at focus
Yes, sir.
with the same angle of reflection. So talking about this angle, so this angle will also be theta. No problem. Okay. Focal length is basically the distance between the focus, distance between the pole and the focus.
Yes, sir.
Distance between
Pole and focus.
pole and focus means this distance. This distance will be the focal length, and focal length we will denote with small f. So this fp distance will be the focal length. In case of the convex mirror also, you can say the focal length will be the distance between the pole and the focus. So how to calculate the focus? How to calculate the focal length? So this
Yes, sir.
distance PC, this distance PC will be the radius of curvature. Okay, talking about this distance. So this distance will be the radius of curvature. Distance between the pole and the center of curvature is the radius of curvature. We know. Okay. Distance between the pole and the center of curvature is radius of curvature, and distance between the pole and the focus is focal length. So
Yes, sir.
now see, focal length have the formula f is equal to r minus r by 2 into sec theta. So this is the focal length. F is equal to r minus r by 2. But in our syllabus, in 90% of the time, we will get the mirrors of small aperture. Mirrors of small aperture. So you can write for mirrors of small aperture. This theta this theta is very small. This theta is small. Angle theta is very small. If this angle theta is very small, then you can say cos of theta, theta is very small means theta is tending to 0. Theta is just approximately equal to 0. So you can say theta is tending to 0. So you can say cos theta is tending to 1. So if cos, and what is cos theta? Cos theta is equal to 1 upon sec theta.
Yes, sir.
1 upon sec theta. So you can say that if cos theta is tending to 1, so this is 1. So sec theta will also be 1. So you can say sec theta is tending to 1. So tending to 1 means sec theta will approximately equal to 1. Sec of theta you can write approximately equal to 1. So now put the value in the formula of the focal length. Focal length is f is equal to r minus r by 2, r minus r by 2 into sec theta. Now we know that sec theta is tending to 1, so we will put this value as 1. Okay. So we will have what we will have? We will have r minus r by 2.
Yes,
So
sir.
r minus r by 2 is f, again r by 2. So focal length for the mirrors of small aperture is half of the radius of curvature. So this formula is very important, and most of the time we will use this because in our syllabus we will have the mirrors of small
Yes, sir.
aperture. Small aperture means this mirror is very small.
Very
mirror.
small. Yes, sir.
Okay. You can just see with this example. If this mirror aperture is very small, see this value of theta now. Now I am just now this theta is decreasing now. Theta
Yes,
is
sir. Yes,
this
yes,
theta is
yes.
decreasing. So when the aperture is very small, then theta
Theta
will
is also very
automatically
small.
will decrease, and you will get the focal length. Exactly, the focal length is calculated like this: r minus r by 2 sec theta. But in our syllabus, 90% of the time we will use the mirrors of small apertures. So the focal length is half of the radius of curvature. Focal length is half of the radius of curvature. Okay, there is one note point here. Focal length for concave mirror is negative. Is negative. Focal length for convex mirror is positive. So why it is this is, we will see when we will study first the sign convention, and after that again we will see again we will measure the distance between the pole and the focus, and we will see will it be negative or will it be positive according to the sign convention. Okay, so write down this.
Yes, sir. So what's the duration of this class? What's the duration of this class?
Duration class is 1.5 hour. You
Yeah,
want
it's
to
1.5
leave
hours, right?
early? 1.5 hour.
Yes, sir. Yes. No, I thought it was 2 hours.
Hmm.
Done, sir.
Done. Okay.
Done, sir.
Done. Okay.
Yes.
So now we will discuss the sign conventions in the ray optics, and sign conventions will play a very important role in solving the problems. So sign conventions. All the distances, if you have a mirror, this type of mirror, and if you have a concave or convex mirror, if you have, then all the distances are measured from the pole. So all the distances you will measure from the pole. First point. Second point is that the direction of the incident ray is taken as positive, and any distance measured along the incident ray is positive. You can see distance measured along incident ray is positive. Okay. For example, you can take here this mirror. This is a concave mirror. Focus, center of curvature. So if a ray of light is and one thing more here, here is an object placed. Here this is an object. This object is placed in front of the concave mirror, and we want to find the object distance. So first thing, we will always measure the distance from the pole. Second thing,
Yes, sir.
this object will give the ray light incident light like this. This is the incident ray or not, means in this direction, there will be the incident ray, and they are saying the direction in the direction of incident ray is positive, and the direction in the opposite direction of incident ray is negative.
Yes, sir.
Now distance between the pole and the object is the object distance. So for measuring the distance, and you will always measure the distance from the pole, so you will move like this in this direction.
Yes, sir.
So this object distance, in this case, you will take negative. Okay, so object distance you will take negative. So you can say this distance is u, and this u will be negative. For example, in this case, if there is an object placed like this, and due to this object, the ray of light will go like this. This is the incident ray. Incident ray. Okay, so this is the incident ray. So means in this direction, the distance you will measure will be positive, and in this direction, the distance you will measure will be negative. Okay, so what can you say about the object distance? This is the object. So this object distance is the distance between the pole and the object. So this distance will be like this. You will measure the distance like this. So you are moving from pole to object to measure the distance. So this is the object distance, and this object distance will be negative. For example, of this object, there is an image here like this. This is the image. What is this?
Yes,
This
sir.
is image of
Yes.
this object.
Image.
This is the image, and you want to measure the image distance. So from where you will measure the distance? From the pole. So you are talking
Pole.
about
Yes.
distance. You are talking about this distance. Means the distance between the pole and the image. So image distance is represented by V. And this time, what you will say? This V will be positive or negative? Distance V, you will take positive or negative according to the sign convention. Distance can never be negative, but
The distance positive, sir. Positive.
yeah, this is positive because we are measuring this distance in the direction of incident ray, incident light. So V will be positive. And what is U and V? You can write here U is the small u is the object distance, and V is the image distance. Small v is the image distance. First thing is this. After that, height above the principal axis is positive and below the principal axis is negative. So if you are measuring the height of an object or image above the principal axis, it will be positive, and if you are measuring the height of the image below the principal axis, it will be negative.
Yes, sir.
So these sign conventions are very, very, very important. Okay, write down. In 10th class also you have these topics like sign conventions, like
Sir,
focal
but in 10th
length.
class, there was not that much. It was deleted. Like half of the chapter was deleted.
No,
Yes, and COVID it was deleted half of the chapter.
okay. But this year, I think these things, the chapter light is there in 10th
Yeah.
CBSE. So you can say pole is just like a origin.
Yes, sir.
In coordinate axis, we have one origin. All the distances we measure from the origin. So pole will behave here like origin.
Origin.
All the distances you will uh, measure from the pole.
Done, sir.
Okay. So remember this also, if you are measuring the height above the principal axis, then it will be considered as positive according to the sign convention. Height can never be negative. If someone
Yes, sir.
height is 5'6", so it will be never negative. Height
It
or
is a
distance
positive.
can distance be negative? No,
No, sir. No.
distance can never be negative. But according to the sign convention here, we for our convenient or to solve the problem in an easy way, we take the
Yes, sir.
sign convention, and according to the sign convention, the direction of the distance we see, and that direction is considered as negative or positive, and then we can say that suppose image distance is negative, like minus 25 centimeter is the
Yes,
image
sir.
distance. So if that does not mean that the image distance is negative. If suppose the image distance is minus 25 centimeter, it means that the image is forming
Minus
at a
below
distance
the
of
p-axis.
25 centimeter, 25 centimeter from the pole,
Pole. Yes.
yeah, and in the direction of the incident light. And if the height of the image is negative, then you will say the image, suppose it is given that height of the image is 5 centimeter, minus 5 centimeter. So it means that the image is formed below the principal axis and having the height of 5 centimeter. So this is the meaning of the sign convention.
Done, sir.
Done. Okay. So please remember the sign convention. Throughout the chapter, this will be used. And after this,
Yes, sir.
we will discuss rules for image formation in case of the concave mirror. In case of the concave mirror. So there are some rules we have. So this is the concave mirror. This is the focus, and this is a ray parallel to the principal axis. So if a ray of light parallel to the principal axis, after reflection, it will pass from the focus. Okay. After reflection, it will pass from the focus.
Focus.
Second rule, if a ray of light is passing from the focus, after reflection, it will become parallel to the principal axis. So you can say both these rules are just reversible. If a ray of light is parallel, then passing through the focus. If a ray of light is passing through the focus, it becomes parallel. Rule number third, if a ray of light is passing from the center of curvature, if a ray of light is passing from the center of curvature, it will retrace its path. Why it is retracing? If someone can ask why, when a ray of light is passes from the center of curvature, it is retracing its path. So you can say that
Yes, sir.
there that if you will draw the normal, so normal will also pass from the center of curvature. If normal is passing from the center of curvature, and this is the incident ray, then in this case the angle of incidence will be equal to 0. And according to law of reflection, we know angle of incidence must be equal to the angle of reflection. So you can say that angle of reflection will also be 0. That is why this ray is reversing or retracing its path. Okay, this is the another, you can say, rule. This is the center of curvature here. So if this is the center of curvature, so this is a ray of light. So when you will draw the normal, so normal will also pass from the center of curvature. So you can say the principal axis and normal will be same here. So if this ray of light is making an angle theta, this ray of light, incident ray of light, and this incident ray of light is incident on the pole, and this is making an angle theta. So after reflection, after reflection, it will make again an angle of theta. So after reflection, again this will make an angle of theta. Why? Because this is a normal, and this theta is
Yes,
the
sir.
angle of incidence, and this is also the angle of reflection. So both must be equal. So if a ray of light is passing from the pole, it will make equal angle with the principal axis. It will make equal angles with the principal axis.
Access.
So this is the principal axis. The principal axis. Okay, please note down fast.
Yes, sir. You can scroll down.
Scroll down. Okay.
You can scroll down. So the third one, sir.
Third one. So a ray of light passing from the center of curvature, after reflection, it will retrace its path.
So guys, scroll down.
So for the image formation by the concave mirror, these rules will be used. We will use these rules to make the ray diagram of the image formation of an object placed in front of the concave mirror. For the image formation, we have to place the object in front of the mirror, not behind the mirror.
Yes, sir. Yes. Done, sir.
In front of the mirror, or we will. Okay. So we will see now the image formation. So first case here, object is between infinity and the center of curvature. Infinity and the center of curvature. This is the object. And you can say also when the object is placed beyond C. So this object is placed beyond the center of curvature. Okay. So this is the object. And which mirror is this? Concave mirror. Okay. See how we will draw the ray diagram. What is the meaning of the ray diagram? Means we will show how the image is forming with the help of light rays. Okay, with the help
Yes,
of
sir.
some construction, we will do that. I don't know. Here I have placed the object, and we don't know where the image will form. Okay. I know, but you don't know where the image will form. So when we will draw the diagram, na, so we will just we will have the idea where the image will form. So remember one point: for the image formation, at least two rays from the object must be intersected at a point after reflection.
Yes.
For the image formation, at least come se come, at least two rays must meet at a point after reflection, or you can say at least two rays must meet at a point or appear to meet at a point, then only the image will form. There can be the three images, three rays also meeting at a point, then also you will get the image. Okay, so this is the object, and if this is the object, so from this object, first ray is supposed like this, parallel to the principal axis.
Yes, sir.
First ray is parallel to the
Principal
axis.
axis.
And we know that when a ray of light is parallel to the principal axis, it will pass from the focus. It will pass from the
focus.
After reflection, it will pass from the focus. No problem. Now, two rays are required. So
Yes,
second
sir.
ray, I am just passing from this focus. So second ray of light is passing from the focus from this object, and we know that from the rules, when a ray of light passing from the focus becomes parallel to the principal axis after reflection.
Yes. Yes,
becomes parallel to the principal axis after reflection.
Reflection.
And where the two rays will meet, where the two rays will meet will be the image. Will be the image. So this will be the image. Okay, this will be the image here, and here will be the object. So O for object and I for image. You can see these rays. Remember, actually, I have not done it correctly. I think this ray, no? This should be this is not looking parallel. So we should make it parallel.
Sir.
So when you will draw up with the help of the scale, then it will be fine. Okay. So now these rays are actually meeting or just appearing to meeting? Actually meeting. So if these rays are actually meeting, then the image will be real.
Real.
Now, if the object and images are like this, suppose this is the object, object arrow is upward. This is this object, and image is something like this. So you will say the image is inverted image. Which image? Inverted. Image. And if the object is like this, and image is also like this, no matter how bigger or smaller the image is. So in this case, you will say the image is erect or upright. Okay, so here the image is what? Inverted or upright?
The image is upright.
No. See, the object arrow is pointing upwards.
Yeah.
It will be inverted. So here we can.
Yeah, the object is upwards and the image will be.
So it will be inverted. So we can say the image is real and inverted. And talking about the position of the image between the center of curvature and the focus. Talking about the size of the image. Size
sir.
will be smaller than the object, or you can say diminished.
Diminished.
Smaller than the object, or you can say diminished.
Diminished.
Magnification. So magnification, we will have a separate topic, magnification. So there I
Yes,
will
sir.
discuss that magnification. Here I am not discussing this. So formed between center of curvature and focus.
And focus.
Center of curvature and focus. Real and inverted. Real and inverted. Why? Because rays are actually meeting.
Yes, sir. They are meeting.
Reflected rays. Actually meeting. That is why the diminished means smaller than object. The size of the image is smaller than
Object.
object. Very nice. Okay, so this was the object, and here somewhere here the image is formed. So these are the characteristics of the image. Now what we will do, we will take this object and we will just place this object on the center of curvature. Okay, now this is the object placed at the center of curvature. Same thing we will do for the image formation. Two rays. There is a requirement of two rays for the image formation. First ray parallel to the principal axis.
Yes.
And if a ray of light is parallel to the principal axis, passes from the focus after
the
reflection.
Yes.
After reflection, passing from the focus. Another ray of light, if passing
passes
from
the focus, gets reflected in
yeah, it will become parallel after
yes,
reflection.
parallel to the principal axis.
Principal axis.
Yes.
So here somewhere the image will form.
It
like
will be
this.
real and inverted, right?
Yeah, real and inverted. And here
Diminished.
you will see the image will not be diminished. Image will be of same size as the object.
Okay.
So this is the object and this is the image. Okay. Real.
Yes.
This is clear. Real and inverted, same size as
Yes.
the object, and where the position of the image at the center of curvature.
At the center of
this thing I have written here. Formed at center of curvature, real and inverted, same size as the object. Why the image is real? Because rays are actually meeting at a point. Rays
yes,
are
sir.
actually meeting at this point. At this point, rays are actually meeting, you can say. So rays are actually meeting at this point here. After this, what we will do, we will place this object between the focus and the center of curvature.
Yes, sir.
Between the focus and the center of
curvature.
Same thing we will do. First ray from the light will be parallel to the principal axis, and after reflection, it will pass from the focus.
Yes, sir.
It will pass from the focus.
Focus.
And another ray of light is passing from the focus. And after reflection, it will become parallel to the principal axis. So somewhere here the image will form. So here the image is forming. Basically, this image should be behind the center of curvature. So that thing I have to see. Object. Why it's not working? Just a minute. Hmm. So this image is basically forming beyond the center of curvature. Okay, this
Yes,
image
sir.
is forming
Beyond
beyond
the
the
center.
center of curvature. So here somewhere this is the center of curvature, and this is the image. When you will just draw it properly with the help of a scale, okay, then you will get it properly. So this is the image, and this is the incident ray. This is the second incident ray from the object, and
Yes, sir.
this is reflected like this, becomes parallel to the principal axis, is meeting at this point. You can just extend this also, no problem. Extend this also. Well, here the image is formed.
Yes, sir.
This is it. Now, what can you say about the image? This is the object. This is the image. First of all, image is real and inverted.
Yes.
Second is the size of the image is greater than the size
Greater
of
than
the
large
object.
size of the object. Yes.
Object, okay. And another, you can say the image is formed beyond the center of curvature. Beyond the center. Magnification we will. Magnification we will discuss later. There will be a separate topic. So then I will discuss. There I will discuss what will be the magnification. So image is formed beyond the center of curvature. It will be real and
inverted.
And magnified also. Magnified means larger than object.
Yes, sir.
Magnified means larger
than the object.
Larger than object. And there is one note point. If the image, always remember, if the image is real and inverted, the magnification will always be negative. So we will discuss why the magnification will always be negative. There we will discuss. Okay, so this was the earlier. This was the object. Here, yes, our object is here. Now we will place this object at the focus. Okay. Now we will place the object at focus. So we will see. So this is the focus. Yes. And this is the object as focus. Now what we will do? And this is the pole. First ray of light from the object, suppose like this. And as this ray of light is parallel to the principal axis, it will pass from the parallel to the principal axis. After reflection, it will pass from the focus. From the focus. Yeah, it will pass from the focus. Now what we will do? This is a pole, and we know that whenever a ray of light falls on the pole, if this ray of light is making an angle, suppose theta, so according to this angle theta, it will be reflected. After reflection, it will again make an angle of theta. So this angle will also be theta.
Theta.
Now you can see after reflection, both the rays are parallel and these rays are not meeting. So parallel rays are meeting at infinity. Parallel rays always meets at infinity.
Infinity.
So these are the parallel reflected rays. Parallel reflected rays, and these will meet at infinity. Do you know what is infinity?
Yeah, like your
At a very large distance.
yeah, at a very like large object, but which cannot be met.
So where the image will form? If the rays will meet at infinity, so obviously the image will also form. Image will be formed at infinity. So the image will form at infinity when you are placing the object at focus, and formed at infinity. Image is real and inverted. Okay, real and inverted. Okay, and highly magnified. Highly magnified means very much larger than the object.
Yes, sir.
Last case, and very special also. Now you can see here, everywhere you are getting the image real and inverted.
Real and inverted.
Here also, real and inverted. Real inverted. Real inverted. Real inverted. Now we will see how the image we will get. So now you have placed the object between the focus and the pole. Yes, earlier your object at focus. Now you have placed this object between pole and focus. Now object is placed between pole and focus. We will see where the image will form. So for the image formation, two rays are required, two incident rays. First incident rays like this, parallel to the principal axis, parallel to the principal axis, pass from the
focus.
Yeah, pass from the focus after reflection. Now another ray of light okay, another ray of light is falling on the pole, and after reflection it will make equal angle with the pole.
Yes, sir.
We know this rule. If this is theta, then this is also theta. Okay, now these are the reflected rays. These are the reflected rays, and these reflected rays are diverging rays, and diverging rays will never meet.
Yes, sir. They will never meet.
So what we will do? We will produce these rays backward like this.
Yes.
Somewhere here these rays will meet.
Your virtual image.
Obviously the image will be virtual. Okay, so it is very easy to draw the diagram of pen on paper, and on this now it is a little bit difficult to draw. See what is happening. I want to draw the principal axis. Okay, so just imagine this is the principal axis. Okay.
Yes, sir.
This is the principal axis, and where the image is formed. Image is formed behind the mirror, you can say.
Yes.
So this is the image this time, and here the rays are actually meeting. This is the object, and this is the image. Image is forming in the mirror, or you can say in the mirror.
Yeah,
you can
inside the mirror.
Yeah. And this ray, this image is real and so not real,
virtual
and erect.
Erect, yes.
Virtual and erect. Why virtual? Because rays are just appearing to meet. And
Yes.
why erect? You can see.
Because it's straight.
Always remember, if the image is virtual, then it will be erect. If the image is real, then it will be inverted. And where the image is formed? In the mirror, you can say.
Yes.
Or you can say
in the mirror. Inside the mirror.
Formed inside the mirror, virtual and erect, and magnified. Means, what is the meaning of the magnified?
Like the image distance is much larger than the object.
Not, you can say not much larger, but you can say just larger than the object.
Larger.
Larger than object.
Yes.
So Harsh, will you join the tomorrow?
Tomorrow? Yeah, tomorrow I can join.
You will join?
Yes, I guess.
Okay. Okay, so now have you understood now how to draw the ray diagram?
Yes,
it's on pen and on copy, and when in examination, what you have a copy, you have a paper, you have a pen, pencil, eraser, sharpener, and all these things, and there you have to draw the diagram. So before that, you have to practice this, how to draw.
Yes, sir.
What you will do, always you will draw first ray parallel to the principal axis. You can see in each and every case, first ray I have always drawn parallel to the principal axis. And then according to the law, whenever a ray of light is parallel to the principal axis, after reflection from the mirror passes from the focus. So some laws you will use and you will get the image definitely. So now you can just note down it, and rest of the things we will discuss in the next class.
Second, scroll down the second one.
Yeah. This completed this thing?
Yeah, I wrote the things. I just have to draw the diagrams. So can you scroll down? The third one, sir.
Third one.
So you can scroll down. The fourth one, sir.
Have you written these things?
Yeah, I wrote the things. So I have just written.
Okay. Okay.
So you can scroll down. Fifth one.
Only in this case, when you are placing the object between focus and the pole, only in this
Yes.
case the image is virtual and erect.
Virtual and
Otherwise,
erect.
always the image is real and inverted in case of the concave mirror.
Yes, sir.
This is just the special case you can say. Harsh, can you tell me what is the virtual image and what is the difference between the virtual and the real
So
image?
virtual image is formed in the inside the mirror.
You are right, but
And
any other explanation you have?
uh,
The image that you are the image of me you are getting on your screen,
is
image of me, or you
yeah,
can just say you image of the this thing
camera.
is it real or virtual?
Sir, virtual, sir. Erect, sir. Yes, like
No. Okay, the image that you are getting, my image you are getting,
yeah,
is this image real or virtual?
virtual.